Hey everybody, we are going to continue on in Unit 6, which is all about our renewable and non-renewable energy. So we're going to focus first on non-renewable energy. Now, I am going to give you guys a warning that there's a lot of information in this unit. We have to focus on each specific type of energy, what the advantages and disadvantages are. So there is going to be more video notes for this unit than we've had in other units, just because there's so much information. So with that being said, let's get started. Now, looking at non-renewable energy. Okay, so this is energy that once it's used up, it's gone. We can't replenish it for billions of years. So let's write down the definition of non-renewable energy. All right, so non-renewable energy, we say that it exists in a fixed amount. What does that mean? It means that there's only a certain amount of this energy source on the planet. Once it's gone, it's gone. Okay, so it exists in a fixed amount and involves the transformation of energy. Also, is not easily replaced. So the last video we talked about the first and second law of thermodynamics and how that energy basically gets transformed from one form into another. That's what we're going to explore here. So how do we take oil and coal and natural gas and get energy from it? So we're going to look at those processes. Okay, so if we look at this pie chart, this is the breakdown of energy globally. Okay, so fossil fuels account for 81% of the energy that is currently used globally. Now, it's extremely lopsided, and we know that the burning of fossil fuels does contribute to climate change and causes pollution. So hopefully we're going to see this number start to shrink with more technology and development in renewable energy sources. But by looking at this pie chart, you can see that oil, this is the most widely used. Okay, so oil gets used for lots of different things. Our primary use for oil is transportation. Okay, now you can see renewable energy is only used globally 13%, and then we have 6% as nuclear energy. So the access to these non-renewable energy sources basically depends on the geologic history of the location that you're living in. Okay, so distribution depends on geologic history. So what does this mean exactly? So when you say the term fossil fuels, what are we actually talking about? And you've probably heard that, yeah, it's dead dinosaurs and stuff that have been liquefied and or become coal, which is partially true, but mostly it's decomposed archaic plant matter. So if it's a swampy area, you're going to have more fossil fuels than you would in a desert area. So it just depends on the geologic history of the planet. Okay, so typically we know that coal is going to come from plants, fossilized ancient plants. Okay, oil typically comes from phytoplankton. There's that word again. We can't escape phytoplankton. Remember, phytoplankton are the plant, the plant form of plankton. Okay. All right. So let's look at fossil fuel usage per person. And to me, this is a mind-blowing graphic because the United States, we're using twice as much as the next country. So per person, it's incredible how much fossil fuel we use in the United States. We're the #1 consumer and polluter based on fossil fuel usage. So you can see that the use of these energy sources is not evenly distributed. So I mean, compare United States to Pakistan, Bangladesh, Ethiopia. These are developing countries. They do not have equal access to these energy sources. So it is extremely lopsided. Okay, so the use of energy resources is not evenly distributed. So, well, you know, a lot of it does depend on wealth, guys. Developed countries use more. We can clearly see that from this graphic. So developed countries use more. Now, as a country, this is a big point right here, guys. As a country becomes more developed, think about that demographic transition model where you move from a developing to a developed country, okay? So as a country becomes more developed, they become more dependent on fossil fuels. They use more fossil fuels. They use more fossil fuels. Okay? So basically, we see a correlation when you have an increase in industrialization. Okay? We also see an increase in fossil fuel usage. Okay? All right, so this basically is explaining the steps that are taken when you extract the fossil fuel, the amount of processing it has to go through, and then the transportation to where it needs to go, and then how it gets converted into electricity, which is what a lot of the fossil fuels get used for. Okay, the electricity here in our region of Texas comes from the burning of coal. Okay, so the #1 goal is you always have to have a profit. If you're in a fossil fuel business, you're any kind of business, you got to have profit. So the profit has to exceed the price it costs to extract it. Okay, if it costs more to extract it, you're not going to have any profit. So profit must exceed the cost of extracting and processing. Okay. All right. So you have to identify where the energy source is. Okay. So where is the oil, the coal, the natural gas? You have to extract it. You then have to transport that raw material to a processing plant. And I'm referring to this image right here, guys. Okay. So once it's in the processing plant, it then gets converted through combustion into an energy source. Okay, we're going to talk about this step right here in just a second because you need to understand how this actually happens. Now, there is going to be waste, so the waste has to be transported away and disposed of properly. So then you'll have electricity generation, and then it gets sent to the user right here. Okay, so let's look right here. Now, this is using a coal plant as an example, but this basically is the exact same process we're going to see in lots of these renewable and non-renewable energy sources. How do we get this energy source converted into electricity? Okay, that's what the power plant is for. So this process, you're going to see me repeat over and over again. It's the same pretty much for everything. Okay, so let's look at how this works. Okay, so here we have our coal. All right, so our coal is going to be essentially, after it's pulverized, you've got to smash it into smaller pieces. It's going to be burned. Okay, so the fuels are burned to create heat. Okay, so when you have this coal, for example, being burned in these incinerator units, okay, so this is going to be an incinerator. What is happening? Oh, okay, now it decides to work. An incinerator, okay. We have water running through the incinerator unit, okay. Guys, all of this is based around the heating of water, okay. So you have water that's piped through the incinerator unit. When water gets heated up, what does it produce? Steam, okay. So the heat in the incinerator unit turns the water into steam, okay? Now, the steam, we're talking about water vapor in the air. It has motion. It gets piped into a turbine. Now, turbine is kind of a generic term for a motor that turns. It turns and turns and turns. If you think about a windmill, guys, those things that rotate like this, those are called turbines. Okay, so the steam is used to turn the turbine. Okay, which when the turbine is spinning like this, it's creating kinetic energy, and it powers the generator. Okay, the generator is then creating the electricity. So you can see it is connected to the power lines or the transmission lines. So the generator is what is creating electricity. Okay, so the power lines are connected, and then these transmission lines, guess where they go? To your house. That's how this works. Okay, so we want to make a note down here. We also need to remember that steam turns a turbine which generates electricity. Okay, this is the process. We have incineration of the fossil fuel, which creates steam from water. So it heats up water to create steam. The steam turns the turbine, which then causes the generator to create electricity. That is the central theme in all of these types of energy sources. Okay, so this is literally what's happening right now at a power plant to bring electricity to you right now. Okay, all right, so we know that there are 3 types of fossil fuels. We have coal, crude oil, and natural gas. We are going to discuss each one of these in detail. So 3 types of fossil fuels. Okay, now the last thing I want to point out really quickly before my time runs out is this process called cogeneration. Okay, so if you go back up here and look at this picture, all right, what happens to this energy, some of this energy that's not being used? Okay, so cogeneration means that the energy not used can heat a building. And a lot of countries do this. All right, I'll see you in the next video.